Hello everyone, in this video we are going to learn about the chapter electronic devices, and this is the first part of the chapter. So first of all, what is electronics? Electronics is a branch of physics which deal with the flow of electrons. So we can classify metals, semiconductors and insulators on the basis of their conductivity. Metals possess very low resistivity, so they have the high conductivity. Whereas semiconductors has high resistivity or conductivity intermediates to metals and insulators. Like the resistivity for the metal varies from 10 raised to power minus 2 to 10 raised to power minus 8 ohmmeter, and for the semiconductor 10 raised to power minus 5 to 10 raised to power 6 ohmmeter. And for the insulators, they have the very high resistivity or low conductivity. Semiconductors are of different types. The first one is the elements semiconductor. Like these semiconductors are available in the natural form and they are created from the elements. For example, silicon semiconductors, germanium semiconductor. These are the elemental semiconductors or element semiconductors. Second one is a compound semiconductors. These semiconductors are made by compounding the metals, like by making the compound of the two elements like germanium, arsenic. Such type of the semiconductors are known as a compound semiconductors. In this video, we are going to learn about the semiconductor devices, and there are the large number of the advantages. As they are small in size, they can easily operate at a low voltage, they consume less power, they have high life and the long durability. Band theory of the solids. In a substance, as many atoms are close to each other, the energy levels of the atom form a continuous band wherein the electron move. This is called band theory of solid. We know that in an atom, the protons and the neutrons, they are taking the part in the center of the atom, that is called as the nucleus. The electrons, they revolve around the nucleus in the definite orbits, and all electrons in the same orbit has the same energy. The electrons in the innermost orbit, which are completely filled, they have the complete valence electrons, whereas the electrons in the outermost orbit, which do not completely fill that shell, are called conduction electrons. We can consider an example of the silicon and the germanium, as they have the 4 electrons in the outermost shell. So now we can classify conductors, insulators and semiconductors on the basis of the conduction band. So depending upon the respective position of the valence band and the conduction band, first of all we are going to study about the conductors. The conduction band and the valence band partially overlap each other, and there is no forbidden energy gap or no any energy gap in between them. The electrons from the valence band can easily move to the conduction band, and hence large number of electrons are available in the conduction band. So for such kind of the materials, their resistance is low and conductivity is high. For insulators, we can see that a large energy gap exists between the valence band and the conduction band. The energy gap is so high that the electrons from the valence band cannot move to the conduction band. So there is no electron in the conduction band, so electrical conductivity is not possible. Now for the semiconductors, we can say there is a finite but a small energy gap exists between the valence band and conduction band. At room temperature, some of the electrons acquire energy and then they go to the conduction band, and hence they have some little bit conductivity but not more than the conductors. Hence at a higher temperature, they show the high conductivity as more number of the electrons can move, but their conductivity always lie between the conductors and the insulators. Their resistance is also not high as the insulator, so they lies as the intermediate between the conductors and insulators. So there are the two types of the semiconductors, intrinsic semiconductor and the extrinsic semiconductor. So for the intrinsic semiconductor is the pure semiconductor free from impurities. So also they have the low conductivity, and their conductivity is known as the intrinsic conductivity. So we can consider the example of the pure germanium and the silicon. Both have the 4 valence electrons. One thing to keep in the mind that semiconductors always have the 4 valence electrons. So when the temperature is 0 Kelvin, so in the crystal structure of germanium, or we can take the example of the silicon, 4 valence electrons form the 4 covalent bond by sharing of electrons with the neighboring atom. Each covalent bond is made of the 2 atoms, each from 1 atom respectively. By forming covalent bond, each germanium atom in the crystal behave as if the outermost orbit of each atom is complete with 8 electrons, and they have the no free electrons because they create a bond by sharing, and there must be the 8 electrons in the last shell. And what happens at a room temperature? The conductivity is possible at the room temperature if the electrons break away from the covalent bond and are free by the thermal energy. When electrons break away from the covalent bond, then empty space or vacancy left in the bond, that is called as a hole. An electron from the neighboring atom can break away and can be attracted by the hole, creating hole in their respective place. So hence we can say that in a crystal structure we see electron break the covalent bond and they keep moving. Similarly, due to the attraction of the hole and the electron, hole also keep moving in the crystal. So thus breakage of a covalent bond produce one free electron and one hole in the crystal. In an intrinsic semiconductor, the most important thing that number of holes is always equal to number of the electrons. As many number of the holes are created, that are always equal to the as many number of electrons that break their bond. So Ne is equal to NH is equal to Ni. Ne represent the density of the number of the electrons, NH represent the density for the number of the holes, and Ni represent the number density for the intrinsic semiconductor. And for the energy band theory, there is an energy gap of about 1 electron volt between the valence band and the conduction band. At temperature 0 Kelvin, in terms of energy band theory, the valence band is full, but the conduction band is empty, as no electron is available in the conduction band for conductivity. So the crystal behave like electrical insulator. But at room temperature, thermal vibrations of atoms provide energy to the electrons in the valence band to cross the energy gap and moves into the conduction band as the free electrons. This result in the electrical conductivity of the semiconductor. As the electron moves from the valence band to the conduction band, so there is a vacancy created in the valence band, and this vacancy is known as hole. As the electron moves in the conduction band, the hole moves in the valence band, and the electrical conductivity is possible. So in this way, at very high temperature, when electric field is applied, the hole move towards the negative potential, giving rise to the hole current, and the electron move towards the positive potential, giving rise to the electron current. Now the second, what are extrinsic semiconductors? Extrinsic semiconductors are not at all pure. These are those semiconductors which are made by doping a pure semiconductor with the impurity. They are of the two types, N-type and P-type. In N-type semiconductor, the electrons are the majority carriers while the holes are the minority carriers. Whereas in P-type semiconductor, the holes are the majority carriers while the electrons are the minority carriers. Thank you for watching. Take care. Have a good day.